Hello friends, once more welcome. So today I have another project to show up. It is an advanced pick and place system. So I'm gonna start my simulation and I'm going to click here a start button and right away show you what's going to happen. So as you watch the simulation, please I remind you all these kind of skills you get them at Reshama Vocational Institute in Jinja for your industrial automation skills and other electrical skills. Please find the contacts on the screen and the location. What you see here is today what we are going to try to program using our PLC, and this factory, remember, is called Factory IO. All the links for the software is used here, don't forget they are found in the description. So as you watch, that is the logic we are going to design. So today we are going to base match on the ladder programming using our GX Works, and that is a software for Mitsubishi PLC. Hope you have seen what is happening. So there we go, you can click stop. So before we do the programming, allow me introduce to you the inputs and the outputs that we have in this project. Those who don't know how to come up here, we have just used an already built scene. This is Factory IO. Open your Factory IO and go direct to the scenes. After going to the scenes, scroll down. Yeah, it is assembler. You can choose the scene assembler. As me, I've already chosen and it's there. So after choosing, we shall have the, let me start with the output devices. Output devices, you can come here to view actuator tags. Wow. So we have this one, grab, is the one that helps us to grab the object. Then we have move Z, it helps us when I click here and I say move Z, say here, so it helps us move the product up and down, as you see. Then we have another output device. We have these conveyors. When I click here, I have this base conveyor, that one moving the base. Then I have this one, another, it's a leads conveyor, that one moving the leads. Then another output device that I have here, clamp base. When we switch it on, that is what happens. When we switch off, that's what happens. I have here clamp lead. When I switch on, that is what happens. When I switch off, that's what happens. I'm showing you the input, the output devices, and those are the actuators that we have. We have here move X. When I switch it on, that is what happens. When I switch off, that is what happens. The grabbing, when I switch on, it releases the gas to grab. When I switch off, it does what? It releases. Then I have another output device here, the positioning. When I switch it on, it raises up. When I switch off, it goes down. So those are the output devices that we have. Then the input devices, I'm going to start from the panel here. I'm going to use this emergency button, stop button, and start button. Those are three input. Then I have the leads sensor, the sensor at the leads conveyor. We have the sensor at the base conveyor. Please analyze this one because we may not come back again after diving into programming. So actually, let me put sensor tags and remove the actuator tags. Here you have to release them first, because if you don't release, the PLC won't be able to control them. then we are going to remove this one. So this is called the base at place, a sensor that helps us to detect the base has reached. This is the leads at place sensor that helps us to detect that the lead has reached. This one, item detected. When this handle moves down, this sensor detects the item at the conveyor. Then moving Z is a sensor that reads that the arm is moving down. Then we have this one, base clamped. When the base is clamped, this sensor is going to do what? To detect. Then you have leads clamped. When this lead is clamped, the sensor is going to detect. I have some other sensors this way. I have here this capacitive sensor here called sensor Z. It detects when this handle has moved away or when it has come back. Then I have some other here. If you are seeing this moving X sensor here, it detects whether this handle is moving or not. So those are the input devices that we are going to use, and we are going to design only an automatic simulation. For a manual one, please, you can task yourself and also try out your skills. We are going to open our MX OPC configurator. We always start our new device, then we add tags. If you don't know how to add tags and how to open and how to use MX OPC configurator, please refer to the previous videos before. So all these X's are the input devices and the Y's are the output device. So you have to analyze this one very well, because we may also not come back behind. So emergency is X0, the stop button X1, the start button is X2. Then the lead sensor is X3, base sensor is X4, lead clamped sensor is X5, base clamped sensor is X6, lead detected sensor X7. Then detecting movements in the Z-axis is X8. When the Z-axis has already moved, that is X9. That is the capacitive sensor. Moving X, detecting X Y-axis movement, that is X10. Then lifted, this one detects when the object or the item, the lead, has been lifted. Those are the input devices we are going to use. Then when we come at the output devices, we are going to have Y0 is the stop lamp, Y1 is the start lamp, then Y2 is the lead conveyor, we have Y3 is the base conveyor, we have Y4 is the clamping of the lead, then Y clamping of the base is Y5, then moving the axis down, that is X axis, is Y6, then grabbing the lead is Y7, moving forward taking the lead to the base conveyor is Y8, then lifter, this is the one that raises up to allow the combination move away, is Y9. So please, if you are not understanding anywhere and you'd like to use this very example in your own practices, feel free to post the comment in the comment section below. Now we are going to do away with MX. Don't close it, you don't need to close it, just you have to leave it in a simulation. You can even put it in monitor mode to check all your inputs and outputs if they're okay. Yep, so there we go. Now I'm just going to minimize this. Now what we are going to do is we are going to open our GXWorks software and open a new project, which is right here. So now we are going to open our new project. If you don't know how to open GXWorks, please find it in the previous videos. So you are going to click here project, you're going to click new project, you're going to follow the steps and say finish. So here we are going to start with the ladder programming. So remember the input devices and the output devices that we have in our system. So right away we are going to have here the start. I'm going to start with an emergency, normally open. Then I'm going to have a stop, that is X1. then I'm going to have a start, that is x2, then I'm going to have my first memory, that's M0, then I'm going to self-latch it. So the logic we use in ladder programming is not specific, is not genuine, so ladder logic is developed according to your own wish. So whatever you do to save time, you can be building that one. So now we are going to register the output devices that we have. I'm going to start here with M0, that's the memory. I'm going to give Y0. Remember, Y0 is the stop lamp. This one I'm going to make normally closed. Just come here, it is normally closed, or you can use F6 on the keyboard, then just again rename it M0. It's going to change, no problem. So I'm going to have a normally open of M0, and I'm going to give it to have here. I'm going to have that is why no, it is timer 1. Also give it time 5 microseconds. You say enter. Okay, so we have finished the conveyor, the leads conveyor. It is Y3, the base conveyor Y4, the clamping the leads is Y2 is the leads conveyor, Y3 is the base conveyor, Y4 is clamping the leads, Y5 is clamping the base. So now after that one, we are now going to have how the clamping, these clampings are going to have some other logical control. I'm going to have here my normally open of the M0. It's going to be started by X3. Now, do you know what X3 is? This sensor here that senses the leads is X3. This sensor here that senses the bases is X4. Don't forget, we have addressed all of them here, so don't be left out. So here X3, that's normally open of X3. Then it's going to power our memory M1. This is now another memory which is going to self-hold itself, M1. Very good. So this M1 is going to power, is going to clamp the leads here. I'm going to put here normally open of M1. Very good. So we are going to go to normally to clamping the bases on the base conveyor. I'm going to have here normally open of M0. I'm going to have X4. Hope you still remember X4 is going to start memory 2. And memory 2 is going to self-hold itself. So also memory 2 is going to power this timer that is going to clamp the bases. And we are going to have there normally open of memory 2. Very good. Now, after clamping, remember these clamps, when they continue retaining power, they will remain clamped. For them to go back, we must switch them off. How are we going to switch them off? Switching them off, we have when this clamp is clamped, it has, when you come here to view sensor tags, yeah, it is sensor tags, or again I've removed them. To view sensor tags, we have this sensor of lead clamped and this sensor of base clamped. Are you seeing? So this is X5, this is X6. So when this one clamps and it reaches that sensor, it's going to switch itself off again so that it goes back. The same is going to happen here. Now you see here I'm going to put normally open. It has to be normally closed of X5, and I put here a normally closed of X6. There we go. Compile. I'm going to build this one. Yeah, so now that's how we are going to move. At least we are done with the logic of clamping. What next? Now another thing, so when we come to these conveyors up here, that is Y2 and Y3, these Y2 and Y3 actually they need self-hold themselves. They are going to come here and say edit. I'm going to insert some row there. I'm going also to come here and edit, insert some row. So here on Y2, just click around here. I'm going to put a self-holding, that is Y2. Also come around here, put a self-holding of Y3. So since they are self-holding, remember this timer 0 here, timer 0 is switching on Y4, that is the clamping. So when those leads and the bases are clamping, these conveyors have to stop and wait for the clamping. So that means this timer 0 also has to switch off these conveyors. Oh, so logical. Timer 0. Now also our start and stop, I mean the emergency and the stop buttons also have to switch them off. That's X0 and X, this is normally closed, X0 and X1. So the same here, that is X0 and X1. They will have to switch them off, but also these conveyors, they have to start. Now when we move the objects, when the objects have moved and they have reached, when this clamp here moves up the positioner, I can give you here a view. Actuators, when I move that base up like that, the conveyors have to start to allow the leads and the bases to go and the others also to come. So when that one happens, this sensor here is going to be activated. As you see, when I switch off, the sensor is now inactivated. So what happens is, that is also a mechanism we are going to use to restart these conveyors. So allow me add another row here, insert row. So this one, that sensor, remember it is here, we call it X11, and that is the lifted sensor. So for it being X11, I'm going to put it in parallel here like that. The same is going to apply to X2, I mean to Y2 conveyor. Edit, insert row. Around here I'm going to put it in parallel, and that's X11. So that is the logic how we are going to start and stop those conveyors and the clamping. We are going to come to compile, build our ladder logic. We still continue. Now we are going to move to another output devices, an output device, and that's Y6. What is Y6? Y6 is moving down the x-axis for the handle to go and grab the item. So I'm going to have, it is also going to somehow be controlled after a given time interval but also after sensing, after a certain sensor reading, it's the one going to initiate the timer. So here I'm going to have a normally open of memory 0. I'm going to power timer, and that is T. Oh, I've given it timer 0 we have already used. We are going to use T2, and T2 we are going to give it also around 5. So this one, just come here again, click normally open, and just put T2. It's going to change to T2. Okay, so that T2 is going now. That one to power, allow me first put another output here. That is, this is Y6 is the moving in Z axis, so I want to put Y7 for moving in the X axis, that is taking the lead to the base side. And I'm going to have here, so this Y7 that is moving in the Z axis is going also to be controlled by some timer, and now that is timer 3. So I give it the coil Y7. So now it is normally open of M0 that's going to control Y7. I mean that's going to control that timer, and that is T3. And T3 I'm going to give it also just some little time, that is 5 microseconds. Now another logic comes here, how to control those movements. We want, I'm going to start up some another mechanism, automated mechanism of memory M3. Before that, let me put all the outputs. I will have also another output. Can have here timer 4 is going to control output 7, that is Y8, and Y6 is the what? Y6 is the Z movement, Y7 is the grabbing, then Y8 is the what? The X axis movement. This is moving down, then grabbing the lead, then taking it to the base side. Very good. So this timer 4, I mean this Y8 is going to be controlled by timer 4, which is going to be controlled by our memory 0. So here is timer 4, also some little time. Timer 4, I'm going to increase its time a bit. It has to wait for some time. Now I'm going to create some automation here. I'm going to have here memory 0. It is going to pass through the normally closed of X9. Who knows what X9 is? X9 is our sensor here that detects that the lead has been taken, and that is the capacitive sensor. So when the lead has not been taken, that is why it is normally closed. Then that means X8. Who knows what X8? X8 is our sensor which is moving Z. So when the lead is not taken and the Z movement takes place, that is when it's going to power. No. Okay, that one is going to power another timer called timer 5. Though we have not yet used it. Timer 5, and timer 5 is going to self-hold itself. So there we go. Now before we reach that timer 5, I had wanted to put something in the middle here, start row, and that is M0 is going to be started by sensor X5. Do you know what X5 is? Then it has also to pass through the normal open of X11, the positioning sensor, to power another memory that I'm going to call M3. And that M3, I want it to latch, self-hold itself. I'm going to put a row there and self-hold this one, M3. Okay, now what's the role of M3? M3 is going to start timer 2 to power Y5. M3 is going to start Y6, Y5. M3 is going to power timer 2 that is powers Y6, not Y5 here. So here I'm going to have M3, and M3 is going to self-hold itself. So I'm going to come here, edit, insert row, and put timer 2. It is going to self-hold itself, and that movement is going to be stopped by sensor by an output Y7. Y7 has to be closed. So here is why I had put Y5 is going to power off this one. I mean timer 5, like that. Then also this one Y6, and what is Y6 we are talking about? Y6 is the down movement. So this down movement is going to happen when it is still at the leads to go and pick the lead. But when it comes back, it has to go to the bases side and take the lead down, and also it repeats the same procedure. So I'm going to add another mechanism here. It is going also to be started by X9. Please, you must be knowing all the sensors the way you have addressed them. Then X7, then I'm going to have to join it from around here. Like that. So that's the complete movement for the down and up, down, up, down, up at the lead side, also down, up at the bases side. I'm going to come here, compile, build this one. So Y6 is already controlled. So Y7, that is taking the object back, that is X-axis. Y7 is controlled by timer 3. And how is timer 3 controlled? Timer 3 is very simple. We shall have here X7, then we are going to have a normally closed of timer 5 is the one going to power off. Yeah, normally closed of timer 5. Wow, so that one is going to control Y7. And I think that one is done. Those ones, the movements are done. Now what is remaining? We are remaining with only one output. That is going how to control Y8, and Y8 is raising up and down of the limiter at the conveyor to allow other objects move away. So which is controlled by timer 4. And now how do we control timer 4 here? Timer 4, we are going to have here X7, that is the sensor. Normally open X7. It is going to start it. Then after that one, also together with X8, and also it must have X11. Wow. Then of course it has to self-hold. It is going to self-hold jumping X7 and X8. What do I mean? Here, let me insert somewhere here, edit, insert row. So I'm going to have here normally open of timer 4 self-hold itself, and I'm going to put a branch here like this, another branch here like this, then a connector here like this. So that one is the logic that is going to start timer 4, and timer 4 is going to power output 8. Don't forget what output 8 is. Then to repeat the whole procedure and end everything, I have one more logic here, that is M0 normally open of timer 5. I'm going to have normally closed of X9. Then I'm going to have what we call Y9. That is the last output that we got. And what is Y9? Y9 here is the lifter. Yeah. So I'm going to build this. Please, that is our ladder logic. It is complete. And go up, view it slowly. Yeah, so you can take the video back and follow step by step. So after that, you are going to come here online, write to PLC, slowing down a bit here, write to PLC. Don't forget here, select all, then say execute. Say yes, yes to all. Okay, you say yes, say close. So now that one is already done, the programming. So what you can do now, we go to factory IO, we come to files, we come to drivers. Please, if you don't know how to connect factory IO to the GXWorks, refer to the previous videos. You are going to come here in configuration, go and select the OPC server, which is our Mitsubishi server. Then we are going to browse. You say this is okay, no problem. Yeah, then after you just go back. So after browsing those nodes, you are going to see all these items are going to come the way we listed them in our MX OPC configurator. We have, so what is happening here is what we have in this configurator. If you don't know how to add these tags in the configurator, refer to the previous videos. So here we have base clamp, base clamped. This is base clamp output. Base clamp is a sensor. We have base conveyor, we have base sensor, we have down movement, emergence. So we are supposed to grab all these input devices and just drag and drop them in the positions here the way they are, and also all these output devices, drag and drop them in these positions the way they are. If you don't know how to drag and drop, please just refer in the previous videos. After, don't forget to click connect. Here it must give you a green tick, then you go back. So my work is done. What is remaining is to start play and see what is happening. So from there, I'm going, let me first give a try and see if it is okay. I'm going to click start. Wow, it is raining, don't mind. Oh, when we click start, it doesn't start. What could be the problem? Let's check our ladder logic. Oh, Y2 and Y3, they have opened. So here we made an error. This one is supposed to be normally open x0. Also this one open x1. This one also has to be open x0, and this one also has to be open x1. Yeah. Also we have something else to correct here. Here x11, the x11 you must use normally closed. Say okay. Here normally closed. You say okay. Yeah. Also x9 here is normally closed. You compile, build, you say yes. So okay, I think there now everything is lively. Yeah, as you can see, Sabula. So that is what happens once more. Get all these skills at the Rishama Vocational Institute, Jinja. Contacts and the location on the screen. Try out your lab. Oh, that is an error, in the machines. So that is the logic, that is the simulation, how we go about with the scales of PLC programming. It has been quite hectic, but if there is any step you didn't capture, please, more so starting up these softwares, you can refer in the previous videos. Don't forget to subscribe and like. Then if there is any concern, please can drop a comment in the comment section to be attended to. Thanks for your time. So see you when you see me.